Thanks for taking the time to tune into this video. If you need to pause it and reread the problem before listening on, go ahead and do so. We are asked for a volume of Earth that is going to be removed, but we need this in cubic kilometers. So keep that in mind that the final answer is going to have to be measured in kilometers cubed. So that's our goal. We've drawn a picture of this basically chunk of Earth that has been removed in the shape of a rectangular prism just to make this a little bit easier to grasp. Now, you might know from your studies of geometry that the volume of a rectangular prism is going to equal the base area, I'll just call that B, the base area multiplied by the length of that rectangular prism. Now, this question told us that the base area is 75 hectares, but then it told us that the depth, which is basically the length in the picture, is 26 meters. So just pause right there and notice the discrepancy that the base area is given in hectares, but then the depth is given in meters. So we're not going to be able to really effectively calculate the volume when those units are inconsistent like that. So our first step would be to take the 75 hectares and try to convert it into a more consistent unit. And we're going to be able to do that because the problem stated that a hectare, right there, a hectare is defined as 10 to the power of 4 meters squared. So how do we do this? Well, let's go ahead and say that B, the base area, is going to equal 75 hectares. We'll just use a lowercase h for hectares. And then we're going to multiply by a conversion factor. Now, when you multiply by a conversion factor, you want to make sure that the unit you're starting with is represented in the denominator of your conversion factor. So if you're starting with hectares, you want to make sure that you put hectares in the denominator of your conversion factor. Now, again, the problem stated that 1 hectare is defined as 10 to the power of 4 meters squared. So what we do is we multiply the 75 by this 10 to the power of 4 over 1, and when we do that, the hectares will cancel because hectares on top divided by hectares on bottom would equal 1. So the unit effectively cancels. So now we see that the base area is going to simply be 75 multiplied by 10 to the power of 4, and that is now in meters squared. So that is a unit, meters squared, that is consistent with the unit of the depth given in the problem. Remember that the depth was in meters. We've called that depth the length of this chunk of Earth, so depth and length are the same thing for this problem. So this means that the length of our chunk of Earth is 26 meters. So now that we have the length and the base area in consistent units, we can now calculate the volume of this chunk of Earth. So recall that the volume was the base area times that length. So we're going to go ahead and take our base area that we converted into meters squared, and then just multiply that by the length, which is in meters. Now, ask yourself, what unit will I get when I multiply these two quantities? And you can see that when you multiply meters squared by meters, you would get meters to the power of 3, and that's also known as cubic meters. So now we just multiply 75 times 10 to the power of 4 by 26, and we get this rather big number. So the volume is going to equal 195, and it looks like there's 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5 zeros. So that would be the answer in meters cubed. But remember, this question wanted the final answer in kilometers cubed. So we're still not done yet. We have to do another conversion. So let's set that up. Let's go ahead and take our large number of meters cubed, and we're going to set up a conversion. So we're going to multiply by another conversion factor. Now, you probably have learned in this chapter that you can convert from kilometers into meters or vice versa. Perhaps you now know that 1 kilometer is equivalent to 10 to the power of 3 meters. Now, be careful here, because when you look at this meters cubed unit, and then you look at the bottom of our conversion factor, they're not quite the same thing. The bottom here is meters rather than meters cubed. So do you think those units will cancel? And of course they won't, because the only way they can cancel is if they are identical. So we're still not out of the woods here yet. We still need to convert further. Now, the trick to this is to just set up another identical conversion factor. So 1 kilometer, once again, is 10 to the power of 3 meters. So now when you look at things carefully, on the bottom you've got meters times meters, which is of course meters squared, but that still won't cancel with meters cubed. We're not quite there yet. So you guessed it, we have to do another conversion factor. So we're going to do one final conversion. 1 kilometer, again, is 10 to the power of 3 meters. So now look at the bottom carefully, all of the bottoms, and you have meters times meters times meters. And of course that collectively is meters cubed, and that will cancel with the meters cubed that we're starting with. So you can cancel the meters cubed that we're starting with, and then all three of these meters will cancel along with it. Now ask yourself, what unit would you be left with? And of course, you're multiplying kilometers by kilometers by kilometers. That is kilometers cubed. That is exactly the unit that we want to do, or that we want to have. So let's take this large number and then multiply it by 1 over 10 to the 3 times. Alternatively, you can divide by 10 to the power of 3 times. And when you do that, you will get a final answer of approximately 0.02 if you round. You can also say 195 if you want to get specific. That would be the correct number of kilometers cubed, and this indeed is the final answer to this question.